Okay, so when you're looking at any graph, polynomial, you're gonna look at the highest degree, and in this case, it's a 2, which means that it's gonna be a parabola either opening up or down. And because this is a negative in front, it's gonna basically open down. And so here's an idea of what we're looking at. And the important thing when you're looking at a parabola, and if it's opening up or down, are going to be these points here, which are the x-intercepts or the roots. And in order to find these x-intercepts or roots, we're going to want to factor. And so if we factor this quadratic and maybe even and set it equal to 0, you're going to be able to find the roots or the x-intercepts. So to find the x-intercepts, we want to factor and solve, which is, setting it equal to 0. So the first thing I want to get rid of is this negative. If we multiply everything by a negative, you would end up changing the signs of each thing. So this is each term is going to change, and 0 is just going to be unchanged. -1 times 0 is 0. So pretty much this negative distributed here and change all the signs below. And then what I'm going to do is pick two numbers that multiply to give -2 and add to give -1, which will be -2 and +1. Those will multiply to give you -2, and they would combine to give you -1. So then we could take these and make factors, and now I can set these factors equal to 0. So each one of these is going to be equal to 0, and then we'll solve for x, and we'll get these two. These are the solutions or the roots or the x-intercepts or the zeros. So that's going to help with this graph here a little bit more accurate. So let's see. If I have +2 and -1, those are going to be those x-intercepts. But then the next question is, well, I guess that's it, because the main thing is to understand the boundaries here. Here's the boundaries, and that's basically going those two numbers, -1 and 2, for the integral. So that means that we're gonna get everything between these two. And so this one's nice because between these two boundaries, -1 and 2, the graph is above. The only reason why you would want to graph it sometimes, and here's a scenario where, doing the same thing with the factors and everything. Like imagine if you had something like this. And so you would, let's say that the boundaries to find the area would be between these two, boundaries here, 1, 2, 3, like -4 and maybe 3 or something. The issue here when you graph it is you see that this part is above the x-axis and this part is below the x-axis. And if that's the case, then you'd have to have an integral from, let's say this is like 0.5 or something. You'd have to have two separate integrals for, this function, and then also add it to the other integral. Let's say it's from, from here to here, it's below, so you'd have to take the integral of that function as well. And this one would be because it's underneath the x-axis, this one would be negative, when you do the integral and set these, plug these in. And so you'll just, take the absolute value, of it, and you'll have some number here plus some positive number here, and then that'll give you the total area. And that's why, it's important to know where each of these x-intercepts are, because you might have to split it up in order to kind of separate the regions above versus below.